Hi, class. This is Mr. Hart. In this podcast, I want to go over the atom board assignment that I gave in class because I noticed a lot of students struggled with some of the ideas. So I just want to do a couple of examples and make sure you really understand how to find all the properties of an atom because I think this is a really important idea that you'll need in a lot of other science classes. So, first of all, if you didn't get all this written down, or if you're not quite sure to find all these properties, make sure you have this slide written down. Okay, so if I want to find any of the properties of an atom, this is how I would do it. Okay, so if I'm trying to find the atomic mass, usually it's given to you. It's either stated in the problem or it's given as part of the periodic table, but most of the time they'll just say this is hydrogen with an atomic mass of 2, or this is nitrogen with an atomic mass of 14, or whatever it is. Okay, so usually they'll tell you in the problem what the atomic mass will be. Okay, the atomic number of an atom is what you find by going to the top box in the periodic table and looking at the number, usually in the top left corner. Okay, that's the atomic number. Okay, the number of protons in an atom is just going to be equal to that atomic number. That's what it's telling you, the number of protons in that atom. Okay. Then the number of neutrons. This is the one that throws off a lot of students because you may have learned that the number of neutrons is the same as the number of protons in an earlier science class. That's not always the case. Okay. The most accurate way to find the number of neutrons is to take the atomic mass and minus the atomic number. Okay, so if I had an atomic mass of 22 and an atomic number of 10, then my number of neutrons is going to be 12. Okay, that's just an example. Then, to find the number of electrons, that's also equal to the atomic number, or the number of protons. Okay, the number of protons and the number of electrons are going to be the same. The number of shells is going to be equal to the row of the periodic table. Okay, and again, I showed in an earlier podcast why that is, but the different levels have a different, or the different levels of the periodic table have the different number of shells in there. So Mendeleev kind of already embedded that in for us. So it's really nice. So if I want to find the number of shells, I can either draw the diagram or I can just look at the row of the periodic table and it will tell me. So if the atom's in row 3, then it's going to have 3 shells. Okay, and then last of all, if you want to find the number of valence electrons, it's the column of the periodic table. Now, for a lot of students to get mixed up because the columns are kind of labeled differently, but what you want to do is you want to look for the Roman numeral version. Okay, so if I had a Roman numeral that says IV, for example, well, in Roman numerals, that's 4. So that would mean 4 valence electrons. So make sure you're using the Roman numeral designation. Okay, so let's go through an example on this atom board. Let's do lithium-7. Okay, so if I want to find the atomic mass or the mass number for lithium-7, then I know that it's going to be 7 because it tells me right here. Okay, lithium-7. That means lithium with a mass of 7. Okay, to find the atomic number, I'd have to go to the periodic table and find the atomic number for lithium. So let me pull up a periodic table. And there we go, lithium's right here. And you'll notice in the top left corner that lithium has an atomic number of 3. Okay, so atomic number of 3. Oops, wrong tool. Atomic number of 3. Okay, now if I want to find the number of neutrons, okay, this isn't the atomic number. Again, if we go back here, like we said, number of neutrons is the atomic mass minus the atomic number. Okay, atomic mass minus the atomic number. So I'm going to put in 7 minus 3, which is 4. Okay, so atomic mass minus atomic number gives me 4. Okay, number of protons is going to be the same as the atomic number, and the number of electrons is going to be the same as the atomic number. So that's going to give me 3 and 3. Okay, now the number of full electron shells, or the number or full electrons levels or shells, is going to be the same as the row on the periodic table. Okay, so I go back to our periodic table and lithium is on the one, two, there's lithium, second row. Okay, so this 2 right there is the second row. So that means that lithium has 2 electron shells, okay, or 2 electron levels. Okay, so let me write that 2, okay, 2 electron levels. And it's also on the second row of the periodic table. So these should match, okay? And then last of all, we need to find the number of electrons in the outer level, okay, or the number of valence electrons, okay, which is going to be the same as the column on the periodic table. So we go back here to our periodic table, and lithium is on the first column, okay, on the first column of the periodic table. And again, if it was over here, it might have a Roman numeral designation, and that would give us the number of valence electrons. But in this case, it's on the first row. Roman numeral would be I, okay, so that means it has 1 valence electron, okay? And it's also in the first column. So there you go. I found the mass number, the atomic number, the number of neutrons, the number of protons, the number of electrons, number of electron shells, row on the periodic table, number of electrons on the outer level, the column on the periodic table, all just by using simple principles and the periodic table. Okay, so it's really easy. We can figure out a lot of stuff about an atom just by using a few simple tools. Okay, so hopefully that made sense. And let me know if you have any questions. I really want you guys to understand how this works and how we find these properties. But again, let me know if you have any questions, and thank you for watching.